Hey there everyone, what is up? Welcome back to another video. This is part 2 of the series of experimental techniques. So let's start from solutions. So sugar dissolves in water to form a clear mixture. A mixture like this is called a solution. The sugar that dissolves is called a solute and the water is the solvent. So a solute plus a solvent gives us a solution. Okay. What's the definition? Definition of solution is a mix. It's a mixture of one or more solids dissolved in a solvent. Any substance that dissolves in a solid is a solvent. For example, kerosene, petrol, turpentine, etc. A solvent is a substance that dissolves in a solid. Example: water, alcohol, kerosene, etc. Note that water is a universal or polar solvent because it can dissolve in so many solids. When water is the solvent, the solution is called aqueous solution. A solute is a substance that is dissolved in a solvent. When sugar and water are mixed, the water particles get between the sugar particles and separate them. The separate particles are too big to be seen, which is why the solution looks clear. Substances which dissolve completely in a solvent are called soluble substances. Example: sugar dissolves in water. Therefore, sugar is also said to be a soluble substance in water. Grease also, pardon, pardon me, grease also dissolves in kerosene. Therefore, grease is a soluble substance in kerosene and kerosene is a solvent for grease. Examples: water, common salt, turpentine or paint, alcohol, chlorophyll, benzene, rubber, kerosene, coal tar, petrol, grease or glue. So these that were the solvents and these were the substances. FYI. Substances which do not dissolve in a solvent are called insoluble substances. For example, oil does not dissolve in water, therefore oil is insoluble in water. Water does not dissolve in kerosene, therefore water is insoluble in kerosene, and kerosene is insoluble in water. Forms of solution. So we have concentrated and dilute solution. Concentration is when the solute is more than the solvent. There are two types of concentrated: saturated and supersaturated. So, it is said to be saturated when a solution cannot dissolve any more solid at a given temperature. Dilute solution. It is a solution where there is a large quantity of solvent and only a small quantity of solid. You can remember it as excess water and very less sugar. A solution that can dissolve A solution that can dissolve any additional solid at a given temperature is known as unsaturated solution. Factors that affect the rate at which solute dissolves in a solvent: air temperature, stirring the mixture, and the particle size. Okay, effects of solute on the boiling and freezing point of a solvent. Boiling point: the addition of a solute to a solvent increases the boiling point of the solvent. Thus, the greater amount of solute, the higher the boiling point of the solution. For example, when salt is added to water, the water no longer boils at 100 degrees Celsius. This explains why salt solution has a greater boiling point than that of ordinary water. Freezing point: the addition of a solute to a solvent decreases the freezing point of the solvent. For example, salt is poured on icy sidewalks to reduce the rate of ice formation. This occurs because the salt decreases the freezing point of ice as it melts. Hence, it takes a longer time for ice to be formed on the sidewalls. Separation of mixtures. Okay, this is where the main topic is. Separating solid mixtures, you can use a magnet when one of the what do you say? Okay, when one of the solid is magnetic, yes, when one of the solids is magnetic, is to separate a mixture of two solids. One condition must be present: one of the solid is magnetic. For example, if you had a mixture of sand and sulfur and iron chips, you can separate them by pouring the mixture in a dish. Just put a magnet above the mixture, and then the iron chips will immediately get attracted to the magnet, leaving the sand and sulfur behind. Next up, we have sublimation. If you have a mixture of two solids and one of them undergoes sublimation, we can easily separate them by heating the mixture using the Bunsen burner. One solid might melt while the other would directly sublime into a gas. This process must be done in a fume cover in order to collect the gas. Now a solid liquid mixture. Evaporation. You put the solution in a beaker or evaporating dish, set the apparatus, put the beaker on an evaporating dish on the gauze and start heating the solution slowly. The liquid evaporates, leaving the solid behind in powder form. Over here, this is done when you only want the powder and you don't want the liquid that has evaporated. Moving on, crystallization. This method is similar to evaporation, but here the solid forms crystals. Then the crystals are left to dry. Do not dry the crystals in oven because it will evaporate the water of crystallization. After evaporation, the solids will slowly crystallize solutes, and this is heat. Simple distillation. The, this is what it looks like. Okay, remember simple distillation as it comes very handy. Used to separate a liquid and a soluble solid from a solution. Example, water from a solution of salt water, or pure liquid from a mixture of liquids. The impure liquid is heated. It boils and steam rises into the condenser. Impurities are left behind. The condenser is cold, so the steam condenses to the pure liquid and it drops out of the beaker on the beaker. Okay, so we have this is salty water. When it is heated, the pure water vapor will go up. Here is where the cool water comes in, and here is where the cool water goes out. So at this point, it's the vapor, but then the cold water condenses the vapor, and as it comes down from this pipe, it goes down as water, and as we have here, pure water. This method is ideal for distillating seawater. Okay, moving on, filtration. This is a process you are all very familiar with. Let's say a mixture of chalk and water. A filter paper is placed on a funnel. The funnel is placed on a flask. The mixture is poured on the filter paper, and then the chalk, or yeah, this is called the residue, will remain in the filter paper, and the water, the filtrate, this is called the filtrate, will fall down the flask. Fermentation and decantation. These are two processes that come together. The method is very simple. It uses gravity. It involves letting the insoluble solid rest at the bottom of the beaker. Once it has rest, you slowly pour the liquid in another beaker, leaving the solid behind. This is not very efficient, but it can be used. Centrifugation. In centrifuging, a machine is used to separate suspended particles. This machine rotates at a very high speed, and the particles settle at the bottom of the tube. Example, how to do this: put the mixture in a test tube, put the test tube in this machine, start the machine. The centrifugation force will make the mixture separate into two layers, and the liquid at the top and solid at the bottom. They are then separated by decantation. So this one uses gravity, and then centrifugation is often used in blood tests to separate the components of your blood. Liquid mixtures. You can use a separating funnel if they are immiscible liquids. Since immiscible liquids do not mix together like oil and water, when you put them in a container, the denser liquid will settle at the bottom and the lighter one will go up. Water is more denser than oil, so it settles below. So this is the separating funnel. So there's a what do you say, a tap over here. So you carefully open the tap and let all the water flow. When the water is around here and reaches over here, you carefully close it and let the oil stay here. Once you have collected your water in a beaker here, you take another beaker, you separate this one, put another beaker, and you collect your oil. By this, we can separate the two immiscible liquids. Another way is fractional distillation or miscible liquids, used to separate two or more liquids that are miscible with each other. Example, ethanol and water. So this process is shown here below. This is usually used when there's a difference in their like there's a huge difference in their boiling points. So heat is turned on the vapor of all the liquid. The liquid with the low boiling point goes all the way to the glass bead and into the condenser and out of the other side of the liquid. The temperature is constant during this. The liquid with the higher boiling point condenses on the glass beads. When all of the liquids with the lowest boiling point are evaporating, the temperature starts rising again. blah blah blah. Okay, let me explain. Okay, so an electric heater is specifically used so that the temperature or the heat given up can be controlled. We have a thermometer here to record the temperature. So we have, let's say, ethanol and water here. So the water, which has a less boiling point, which has a lower boiling point, it will evaporate first. It will boil first. It will move up while the ethanol will still stay here, and then the temperature over here will be constant. It won't be changing. It goes up here all the way to the condenser. It's the same as the first one we looked at. Water comes in, water goes out. So from water vapor, it condenses and then comes out as pure ethanol. Sorry, not water vapor. I meant what do you say? Ethanol, not water. So water will stay here, ethanol will go up, and then the process. Okay, that should be it. These are some questions. I'll let you all try them, and let me know the answers in the comment below. And I'll mark your answers if they are correct or wrong. And that should be all for the video of this part 2. I hope the videos help. Till then, see you in the next video. All the best on your exams. Bye bye.